Today we are going to discuss non-ideal solutions. In previous class discussed about the ideal and non-ideal solutions. So you know what are the difference of ideal and non-ideal solutions. Then further, non-ideal solutions are classified into two types. One is called positive deviation, negative deviation, non-ideal solutions. Now, what are positive deviation non-ideal solutions and negative deviation non-ideal solutions? You know, non-ideal solutions does not obey Raoult's law and take the range of concentration and temperature. So that is why now we discuss about brief here types of non-ideal solutions, positive and negative deviation of non-ideal solutions. So now we can take here first of all positive non-ideal solutions, positive deviation of non-ideal solutions. Deviation of non-ideal solutions. You say positive non-ideal solutions means if a solution containing two component liquids, if A and B, two component liquids present in the solution. Here components A and B are both are mixed together to form a solution. Here the interactions of component A and interactions of component B, liquid and liquid, these interactions are what happens here greater than that of the interactions of A and B interactions. That means here before intermixing the force of attractions becomes stronger than after mixing interactions between two liquids. So that's why here shows the positive deviation because of here the stronger interaction before intermixing. So then after mixing of the two components, the force of attractions becomes weak. Then both the components evaporation takes place. Due to evaporation, increasing of the pressure. Therefore, the expected vapor pressure here compared to your expected vapor pressure, it becomes more than the expected vapor pressure. That's why you are showing the positive deviation. So for example, if you can take a mixture of ethyl alcohol and N-hexane. Two components are contained, ethyl alcohol and N-hexane. Here ethyl alcohol, before intermixing, here what happens? Here the formation of hydrogen bonds in between ethyl alcohol and ethyl alcohol molecule. Here before intermixing. After intermixing, here N-hexane. Then what happened? The N-hexane molecules interact in between the ethyl alcohol molecule. Then what happened? To broken down the hydrogen bond. Therefore, the interactions becomes weak. Then both the components are escaping more tendency. Therefore, exiting of the pressure becomes more. That is why here shows the positive deviation, means the vapor pressure after intermixing, the vapor exiting of the solution vapor pressure becomes more than that of the corresponding liquids. So that is why here the vapor pressure is showing the positive deviation. So in this case, here see some examples of here conditions of positive deviation. First point is about that is called here characteristics. what are the characteristics of a positive deviation? One is the interaction between AA and BB interactions are stronger than that of the AB interactions. Here, total pressure becomes greater than that of the PA plus PB, or total pressure PT is greater than that of the P0 A into XA plus P0 B into XB. Next, here change in enthalpy of the mixture becomes greater than 0. That means what happened here? Delta H mixture is greater than means the positive value. The positive value means here the dissolving of the liquids are endothermic process. Because of here heat becomes so absorbed. Therefore, increasing the heat means increasing the temperature. Here the solubility also what happened? Increases in this case because of endothermic process. Whereas here the volume of the mixture becomes what happened? Greater than 0. Greater than 0 is nothing but before intermixing volume compared to after intermixing of the volume is slightly raises. For example, if you can take 10 ml of alcohol mixed with 10 ml of hexane, then the resultant solution becomes here not exactly 20 ml. The volume it becomes 20.1. That is more than 20. So 20.1 ml. That means what happened here? Volume is slightly increases. Why? Because here escaping tendency increases due to force of attraction decreases. Therefore, occupying of the volume is more than that of the original volume. That's why the change in the volume becomes what happened? Greater than 0. As well as increases the temperature, the solubility also what happened here? Increases. That's why this process is a endothermic process. The total pressure becomes always should be greater than that of the sum of the partial pressure of the all the components. Next, the interactions are between your component A and component B becomes stronger than that of the interactions of component A and B. So these are the characteristics of the positive deviation of the non-ideal solutions. And as well as here some more examples also can see. Some other examples also. Here some of the examples of positive deviations of the non-ideal solutions. So one of the example here already discussed here, ethyl alcohol plus N-hexane. Here examples of non-ideal solutions. So in other examples I can take here acetone and carbon disulfide. Acetone plus carbon disulfide. Next, third one is benzene and acetone. C6H6 plus acetone. Acetone formula CH3CO CH3. And next, one more example can take here acetone and ethyl alcohol. That is CH3CO CH3 acetone plus alcohol C2H5OH. Can take one more example also, ethyl alcohol and water. So C2H5OH, ethyl alcohol and water. So these are the some of the examples of here positive deviations of the non-ideal solutions. So that is the examples of here characteristics of positive deviations of the non-ideal solutions. Now show a graphical representation for positive deviations of the non-ideal solutions. So now we are showing the curve representation, vapor pressure versus temperature. So now we are showing the dotted lines, ideal curves, means ideal solutions curves. This is dotted line indicates ideal solutions curves. Your xa is equal to can taken as 0. Your xa is equal to becomes 1. Whereas xb is equal to 1. Your xb is equal to taken as 0. So now what happened here? With respect to mole fraction of component A, 0 to 1. Mole fraction increases. This vapor pressure also becomes what happened? Increases. Pa is equal to P naught A into XA. So this is a P naught A. Like that this is a PB is equal to P naught B into XB. This is about P naught B. Here the graphical representation. Here vapor pressure versus mole fraction of the curves. So this is the ideal curves. But positive deviation of non-ideal solution means the shape of the curves are become so like this. This is a thick line of the curves is indicate the positive deviations of the mole fraction. Now you observe here the thick lines are all are above the dotted lines. That is indicate what happens? The vapor pressure becomes so increases after mixture of the two components of the solutions. So that is called here positive deviation of non-ideal solutions. So this is the shape of the curves, vapor pressure versus mole fraction of the positive deviations of the non-ideal solutions. So like that, negative deviation of the non-ideal solutions. Now discuss about the negative deviation of non-ideal solutions. So now, in this case also, can take a two components present in the solution. Here also two components A and B. If the two components before intermixing, these interactions of AA and BB interactions are becomes less than that of the AB interactions. That means after intermixing, the interactions are becomes stronger. The force of attraction becomes stronger. Therefore, the escaping tendency into the vapors are less. Therefore, exerting of the pressure becomes also less. That's why these interactions are becomes less than that of the before intermixing of the two components. For example, you can take here, in this case, here one of the examples can taken as chloroform plus acetone. Already know acetone formula, CH3CO CH3. So this mixture is mixture of the components is acts as a negative deviation. Now you observe here, before intermixing and after intermixing. Here before intermixing here only chloroform molecule. Here chlorines, 3 chlorine atoms and hydrogen. This is chloroform structure. Acetone, after intermixing, what happens here? Acetone molecule here exhibits as the like this structure CH3CO CH3. Here oxygen negative charge, hydrogen positive charge. Intermixing here after components are what happened? The chloroform of hydrogen atom, acetone molecule of oxygen atom exhibits the hydrogen bonds after intermixing of the two components. Then what happened? The force of attractions are becomes stronger. So therefore, after intermixing to develops the hydrogen bonding in between the two liquids. But before intermixing, it exhibits of only polar bonds only. Therefore, the force of attractions are becomes stronger after intermixing. The tendency of escaping is decreases, as well as exerting of the pressure also becomes so less than the expected vapor pressure of the components. That's why it is indicated as negative deviation. This is one of the best example for negative deviations of the non-ideal solutions. So done. Here, what are the characteristics of the non-ideal solutions like positive deviations? Again, here also characteristics of non-ideal solutions. Negative deviation of non-ideal solution. First characteristic is here interaction between AA and BB or becomes less than that of the AB interactions. Second one is about so here the change in enthalpy of the mixture, it becomes so less than 0. Nothing but This process is a exothermic process. Therefore, here the preferable for the low temperature only. So the dissolving of the two liquids. If the temperature increases, what happened here? The solubility of liquids decreases because of its exothermic process. Next, here volume of the mixture also becomes what happened here? Less than 0. Less than 0 means after intermixing what happened? Here the force of attractions are increased. Therefore occupying of the volume is decreased than the original volume. That's why here the volume mixture becomes what happened? Less than 0. For example, here also can take here 10 ml of chloroform plus 10 ml of acetone are mixed together. Therefore the resultant solution becomes less than 20 ml. Nothing but either 19.9 or 19.8 like that. What happened here? The volume is decreased than the mixture of the original volumes of components present in the solution. So that is why here volume becomes what happened? Decrease. Here change in the enthalpy mixture becomes also what happened? Decrease. Means the process is here exothermic process. According to Chatelet principle, for exothermic reactions, what happened here? Increases the temperature, the solubility what happens? Decreases. That's why for the dissolution process, you raise the temperature, the solubility becomes what happens? Decreases. So then these are characteristics of here, and one more is about also the total pressure. It becomes what happened? The sum of the partial pressures of the components of PA plus PB. Therefore here PT is also becomes less than P0 A into XA plus P0 B into XB. So these are the characteristics of negative deviation of non-ideal solutions. So like that, positive deviations. Here also some more examples for negative deviations. You see the examples of negative deviations. Here examples of negative deviations. Here note down. One of the negative deviation of example already discussed, that is called acetone plus chloroform. Formula CHCl3. Second one is about here chloroform, again CHCl3 plus diethyl ether. Formula C2O2H5. Next number 3, chloroform and nitric acid. Again can take chloroform plus nitric acid. Formula HNO3. And one more, nitric acid plus H2O. And also one more example, diethyl ether C2H5 O C2H5 plus chloroform. Sorry, acetone already written here, chloroform and diethyl ether. One more can take an example here, that is acetone and aniline. Acetone formula CH3CO CH3 and aniline ANILINE. Aniline formula C6H5NH2. So these are the some examples of negative deviation of non-ideal solutions. So then you observe sometimes asking what are the differences between ideal and non-ideal solution. Then only write the characteristics. So what is the first one? Interactions. What are interactions? In positive deviations, the interactions are becomes A and BBB. Interactions are becomes here greater than that of the AB interactions. Then to write about some of the differences of your positive and negative deviations. So then to frame the differences between positive deviations and negative deviations of the curves. Just now here also to draw a graphical representation for negative deviations, like positive deviation, vapor pressure versus mole fraction. This is the ideal curves for solutions. Now the shape of the curves here about here, XA is equal to 0, here XA is equal to becomes 1, XB is equal to 1, XB is equal to here 0. So now 0 wave commit, what happened here? This is PA is equal to P0A into XA. Like here, this is PB is equal to P naught B into XB. This is a total pressure PT is equal to PA plus PB. This is ideal curves, you know. But your negative deviations, the negative deviations curves are what happened? The vapor pressures are become so less than that of the original curves. So these are the shape of the curves for negative deviations of the non-ideal solutions. So observe the curves here. Always here the dotted line curves is indicated the ideal solutions curves, whereas the thick line of the curve is indicated the deviation of the ideal curves. That's why what happened here? You know, negative deviation or positive deviations of the solutions are does not obeys Raoult's law. That's why here non-ideal solutions are does not obeys the Raoult's law. But whereas ideal solutions are obeys Raoult's law. So these dotted lines are indicate the ideal solutions curve. So, but whereas non-ideal solutions are indicate the here lower than the top the dotted lines. That's why it is called here negative deviations of the non-ideal solutions. So I hope to understand the what are the difference between ideal and non-ideal solutions. So it is very important in both point of view asking you either difference between ideal and non-ideal solutions or write the difference between positive deviations of the non-ideal solutions and the negative deviation of the non-ideal solutions.